Unit 6. Welcome back. Solutions and expressions of concentration. That's what we are looking into. Mass percentage. Mass percentage is calculated as mass of solute on top here divided by the mass of solution times 100%. So basically, let's say the mass of the solute, let's say it's 10 grams divided by the mass of the solution times 100. So it becomes 10%. So basically, yeah, you want to find out what percentage of the solute does it take. The solution is the holistic thing, but the solute is just a part of the solution. So you want to find out how much percentage does the solute occupy on the total solution, more like a percentage representation. So here it's for mass, it will be done in grams. Then ppm and ppb. ppm is parts per million, then ppb is parts per billion. Parts per million, parts per billion. So parts per billion is grams of solute divided by grams of solution times a million. A million is represented by 10 to the power 6. 10 to the power 6 is 6 zeros, which gives you a million. 10 to the power 9 is 9 zeros. Like that. So this is just a formula. If they ask you to find the parts per million, so you take the grams of the solute and grams of the solution. Then you multiply by 10 to the power 6. So for the parts per billion, it's the same thing, but now you are putting 10 to the power 9. So basically, that's how you calculate them, and we will cover them, the practice questions, more in the exam preparation, which is available on our website. So mole fraction. So mole fraction is like you want to find like how much of component X is in the compound. So what you do is like you find out the number of moles of that component, then the total number of that component. So basically that's it. So let's say the total moles is 20 and the moles of the component is 4. So it will be 1/5, which is more like 0.2. So that's the mole fraction. You can put it as a decimal or as a fraction like this. So mole fraction is dimensionless because it's 4 moles divided by total moles. So the moles, they cancel each other. That's why we are saying it's dimensionless. Okay. Molarity. Molarity. So molarity is moles of solute divided by liters of solution. So you'll be having like your solution here. Let's say it's 1 liter. Then you know that in this solution, maybe there is the moles of a certain substance that's in there. So when you know the number of moles of that substance, that solute, you just say let's say there are 2 moles over 1 liter of the solution. So it becomes 2 moles per liter. So you can see, so moles per liter is represented by an M. So you can say 2M. M, the big M, representing moles per liter. So units of molarity are therefore moles per liter, often denoted as an M, e.g. 2M is equals to 2 moles per liter. So remember, it's per liter for molarity. Then the other one is molality. Molality. So these ones will be using kilograms of solvent. So in this case, instead of using moles, instead of using liters, you'll be using kgs. So let's say the solvent has got 1 kg of solvent, and you know the moles of the solute. So we are saying 2 moles over 1 kg. So it becomes 2 moles per kg. So in this case, units of molality are moles per kg, often denoted by a small m. So they can say 2m like this. So this is called molar, and the other one is molar, the big M is molar, but the other one is molar. Okay, molality is not affected by temperature, as the mass of a substance does not change over time. So if you mass is not affected by temperature because it's the amount of substance. So the substance is not affected. The substance at 100 degrees is the same substance at 0 degrees. So molality is not affected by temperature. So remember, this is kgs. Don't put grams here, put kgs. So then there is normality. Normality is molarity plus times number of electron exchange. So normality is a rarely used expression which denotes the concentration of a solution. N is never less than M. Why are we saying that? Because it's a multiple of the number of electrons. So the minimum it can have, it's 1. If there's 1 electron released, so it's, as you can see, it becomes 1m. So that's why we're saying it can never be below the molarity. So this is just a formula to remember. There's nothing much there. So let's say if you are given that the molarity of a certain substance is 2m, and there are 5 electrons which were released during the reaction or whatever, so the normality will be 2 times 5, which is equals to 10. You understand? So this is basically how it is. So dilution. So dilution is the process of reducing the concentration of a solution by the addition of a solvent. So basically, when you have your oros, if you put it in here at this stage, so when you add water, H2O, the more water you add, the more dilute it becomes. So it means you are reducing the concentration of the oros. So at first, if you pour the oros and you take a sip, it will be too sweet. But when you add more water, you are diluting it, so you are reducing the concentration of the oros. So that's what we mean. So the following mathematical relationship can be used to relate the volumes and concentration of a solution before and after dilution. So it's more like an inverse relationship. When the volume is low of the water here, the concentration will be high. See, concentration will be high when the volume is low. So when the concentration is low, it means the volume is high. The volume is high, which means if more water is added, it will become more dilute. So this is the equation you use. So for example, we are saying, okay, let's change the color here. We are saying we add now water. Yeah. So we are saying at first, maybe the volume here, let's say it was 10. Then when you add water, it becomes 20. So basically what we are saying, maybe we are saying V1, it was 10. Then V2, when you add the water, the volume became 20. So we can say maybe the concentration, we can say at the beginning, we can say it was 5. But now we do not know what's the concentration after you have diluted. So you use this equation now. So you know that C1 V1 is equals to C2 V2. So what you do is like 5 times 10 for the V1. C2 we don't know, but we know the volume is 20. So now what you do, you solve for C. So C2, okay, C2 becomes 5 times 10 divided by 20. So if you simplify with your calculator, you get 2.5. 2.5, that will be your concentration. So basically that's how you apply this formula for dilution. So dilution, so C and V are concentration and volume measured in M for molar, then L for liters. So remember, this was just a hypothetical, so we are assuming that this was 10 liters and 20 liters, and this was like this. So basically that's how we use the equation. So if more practice questions and exam preparation will be covered on our website. So thank you for watching. Please like, share and subscribe to our channel if you haven't. If you have any questions, please use the comment section below, or alternatively use our email on the right. Have a great day. Thank you for watching. Bye bye.